Hello, welcome to this video. Today we are going to discuss this question. I'll read the question for you and explain what do we need to do for solving the question. Calculate the side distance required to avoid a head-on collision of two cars approaching from opposite directions at 90 km per hour and 60 km per hour. Assume a reaction time of 2.5 seconds. Coefficient of friction of 0.7. This has been written wrong. Let me correct it. And a brake efficiency of 50% in either case, right? So what is the given data for us? I have prepared a diagram for you. In this case, V1 is equal to 90 km per hour. For this, V2 is equal to 60 km per hour, right? So reaction time would be is equal to 2.5 seconds. Same has been given in the question as well. Brake efficiency for both the cases would be 50%. So what this 50% will have the effect will the coefficient of friction will be reduced by 50% whenever it is used. So as brake efficiency is 50%, so coefficient of friction for both the cases would be coefficient of friction for both the cases would be equal to 0.7 multiplied by 50%, which would be equal to 0.35 for both the cases, right? So we'll calculate stopping side distance for both the cases. So stopping distance 1 would be equal to 0.278 V1 into reaction time plus 0.278 V1 whole to the power 2 is to be divided by 2 G F plus minus n percent. Since there is no gradient in this case, n would come out to be 0, right? So here we'll put up the values. 0.278 into 90 into 2.5 plus 0.278 multiplied by 90 whole to the power 2 to be divided by 2 into 9.81 multiplied by 0.35. The 0.35 where it has come from? The 0.35 has come from the previous value that we have calculated here, right? So this value will come out to be 153.6 meters. Consider this is the stopping side distance that is required for 90 km per hour of speed, right? So we'll calculate the stopping side distance for the second vehicle. It will come out to be 0.278 V2 plus reaction time plus 0.278 V2 whole to the power 2 is to be divided by 2 into 9.81 multiplied by F plus minus 9%, right? So this will come out to be 0.278 multiplied by 60 multiplied by 2.5, which then 0.278 multiplied by 60 to the power whole to the power 2 into 9.81 multiplied by 0.35. This will come out to be 82.2 meters. So the total distance required for avoiding the head-on collision would be total side distance required for avoiding head-on collision is equal to 82.2 plus 153.6, which will come out to be 235.8 meters. This is the answer to the question. So that's all for this question. We'll again meet you in the next question. Thank you and have a good day.